Good afternoon, everyone, and welcome to Deep Inside Windows 8. So my name is Daniel Pearson, and I work as a Principal Solutions Engineer in Microsoft. And today I'm co-presenting with a man that needs no introduction.
Thank you.
We'll introduce him anyway. Sami.
Okay, yeah. This is probably the first and last time that you're going to have the opportunity to listen to me speaking English in Finland. And I was just asking Dan if he could return the favor and for the first time do his session in Finnish. But
Well, if everyone fills in the evaluation and gives us the highest score, then maybe next year I'll consider speaking in Finnish.
Okay, fair enough.
Is that a good deal? All right. So as I said, welcome to Deep Inside Windows 8. So what we want to do is we want to spend the next 60 minutes, and we're just going to go through and look at some of the new features that have been introduced inside of Windows 8. And not only that, we'll look at some of the other improvements that have been made. So we're going to focus on some core regions or some core areas. So we're going to look at things like scalability. We'll talk about the boot process. So we'll look at some of the changes that have been made in Windows 8 to support newer devices. We'll talk about some of the power improvements. So we'll look at some of the engineering effort that went into Windows 8 to try and make an operating system that would scale not only for laptops, but also for smaller devices as well, such as mobile phones and tablets that are becoming more and more popular. We'll have a look at some improvements made to the registry. We'll talk about services and tasks. We'll have a look at some of the changes that were made in that improvement, or rather in that area. And then we'll finish up looking at kernel memory, and then also we'll look at some of the crash dump improvements that have been made inside the operating system as well. So some of the first changes, scalability. So the system now supports up to 640 logical processors. So Server 2008 R2 had a maximum limit of 256. If you went back to earlier versions of Windows, you could see that in 2008, for example, it had a 64 CPU limit. Now, the reason for this was because of the native word value inside of the architecture the system was supporting. So on a 64-bit machine, you have one bit that can represent each one of those CPUs. So you have a maximum of 64 CPUs. Now, the change in Windows 7, Server 2008 R2, was to actually go ahead and to keep that bit mask, but to actually come up with what was known as groups. So the system would support 4 groups of 64, which would give you a maximum of 256. So now what's happened in Windows 8, of course, is that's been extended, the number of groups has been increased, so it allows for much, much larger workloads. And again, this is all on a single system. There's also support as well for up to 4 terabytes of RAM, so you can get much, much larger capacity from these boxes. Now, in order to accommodate this, of course, there's changes that were made inside the kernel itself, but there are also changes that needed to be made to the tools that the operating system or IT professionals are used to using on top of the operating system. So if we have a look, for example, Task Manager was one of the tools that actually had a major overhaul. So if I just go ahead and I expand here and I have a look at the Performance tab, you'll see now that this looks a lot different than it used to under Windows 7. So here, for example, we have each of the cores. Now, if I was to go and add more cores to the system, if I had a system, for example, that had 160 different cores, I'd no longer actually see the individual graph. What the system actually does is transform to a heat map. So the more activity there is on the CPU, the darker it gets in color. So you can actually look at that and see exactly what's happening inside of this workload. Now, also as well, other tools have been updated, tools like Performance Monitor, and we'll have a look at some of those in a little bit more detail. The system also now supports the ARM CPU as well. So this is actually the 7th architecture that Windows has now supported. So when I talk about Windows, I'm really talking about Windows NT. And actually, it's 2013, so this year is actually the 20th anniversary of Windows NT. So it was actually first released back in 1993. So it had support for 3 architectures back then. There was the i386, also the Digital Alpha, and does anyone know the 3rd architecture?
If we get good answers, we have Windows 8 professional licenses for winners.
We just have a winner there. MIPS, the MIPS PC.
Is that
the
correct?
MIPS. It is correct.
You know, all the other guys only give out these €20 Varusted.net stuff, but
We've got the big stuff.
we got the big stuff.
Okay.
What about your zettabytes? What's the last one?
The last one. There's actually a new file system as well that's been introduced. And so that's a file system called REFS, so the Resilient File System. It's actually not really a file system as such. It's a layer built on top of NTFS. And so this actually allows now for much larger partitions, much larger file sizes. So the maximum file size, for example, is 16 exabytes. It's actually 16 exabytes minus 1 byte, but who's counting? So what that allows then is now for a boot partition, for example, you can have up to 7.4 zettabytes. And if anyone cares to count, there's 21 zeros on the end of that, so 10 to the power of 21. So it's quite a large volume.
The only reason why I'm asking is, you know that Dan works for Microsoft that I don't, so I can ask this question, but I've read somewhere on the internet that the internet itself has data which is equal to about half a zettabyte. So in theory, you would be able to fit everything on the internet and still have some room for a small operating system like Windows?
I think just enough room, and the page file as well, I think.
Oh,
you
page
could probably
file,
get those
yeah,
on the same
that's
volume.
fair. Good.
Okay, so Sami, if you want to talk about some of the new boot improvements.
Yeah, sure. So the biggest one of the boot improvements that we're going to talk about is probably UEFI. BIOS is also ages old and has limitations of sticking to 16 bits and only having 1 megabyte of data in it and no graphics, being slow. So we need something a lot more faster, and the Windows OS team had a limit of maximum of 2 seconds of boot time the post time. So maximum 2 seconds for the BIOS phase of Windows loading. And as it's even quicker, as you can see in a demo in a few seconds, there's actually no time for OEMs to have their brands brought up on the machine. So they had to do a thing called co-branding, which gives the ability of, instead of the Windows logo that you can see when Windows boots up, you can now have the OEM's logo all the time. There's also no time to press F8. You know that if you want to go to safe mode in Windows, you have to press F8, or if you want to go to your BIOS settings, you can press F2. But it's actually so quick that you don't have any time to press any keys. Also, you have slates. You don't even have any keyboards to press anything. So I'm going to show a small demo on a Microsoft Surface and show you how UEFI is working. Now the computer is running. Can you please change the PC? You should have a picture here. If I go and shut down this machine, one of the biggest improvements that we have, if you're talking about shutting down or starting up a computer, is a thing called it's called more of a hybrid boot. It's a hybrid between a hibernate and a real shutdown. So as Windows 7 was, first of all, press shutdown, was shutting down every process in the user mode, and after that shut down the kernel mode itself. In Windows 8, the user mode processes get shut down normally, but after that the kernel itself basically goes to the hyperfill.sys file, so it just hibernates. First of all, this one is a Surface Slate, and if I would like to change the UEFI settings, there's no way of pressing F2 or F10 or whatever you used to press, Del. There's actually 2 ways of doing it. First of all, you can just go to the settings. This is really weird for me because this is the first time I'm doing the presentation in English, but I have my Windows in Finnish because I've never had my Windows in Finnish before.
I was going to ask, do you need any help with the translation? Or?
I wasn't supposed to tell this, but before we were practicing this today, and I was just laughing at that Dan uses Finnish UI better than I do, although I'm native.
I just know where the buttons are.
Yeah. So let's go here. In Finland we have this thing called the yleiset. So here we go. Käynnistyksen lisäasetukset. This sounds amazing. You can press here, or the other way to get to the same place is press Shift key and choose Restart. So if you want to go to UEFI settings from a computer that you don't have a keyboard on it, you press Shift and choose Restart. Or if you want to go to your recovery environment. What this actually does is that there's a variable that can be set by the OS and read by the UEFI. So from the OS, we can say that during the next boot, I would like you to go to UEFI. It's kind of a scary layer because you've never been able to set your BIOS stuff really easily from the OS. So let's go here and more settings, UEFI, and let's restart. So here you're going to see the co-branding. It says Surface all the time. When I'm going to boot this into Windows, you will still see Surface and not the Windows logo. So here we have the UEFI, if you can see it. There's not too many settings in the Surface UEFI. You can see a lot more graphical UEFI user interfaces also. There's also something called the secure boot. If I would like to destroy my machine quite easily now, the easiest way would probably be just to go and delete all the secure boot keys. What those keys mean is that you have a option called or feature called secure boot, which means that you will have to have your OS boot manager signed, and signed by a trusted authority. You can read lots of stories about it, like people are complaining not getting their Linux run on the same PCs, but actually now Linux resellers also have these secure keys, so it's possible even to use that. But I'm just going to exit the setup now, and you can see the normal boot to Windows 8. You used to have to change from the text mode of BIOS to the graphical mode of Windows, because BIOS was very limited when you're talking about graphics. But UEFI supports the same resolution and graphical output protocol, so you can have the Surface logo all the way up here.
So as you can see, there was an extremely quick boot time, so that was around about 7 seconds, a little over 7 seconds. Now, boot was actually one of the major features that the Windows team actually spent a lot of time in, and so there was a lot of investigation looking at finding out why did Windows take so long to boot previously, and looking at different phases that were happening, and also some of the improvements that were made was looking at, okay, what don't we need in this phase? What could be initialized later on? And so as Sami mentioned, one of the improvements, of course, was to go ahead and to use the file, the Hyper file. So in case that stuff is written to disk, it gets read from the Hyper file, and the rest of the stuff is initialized as it was done properly. So there's different tools we can actually use to try and analyze this startup time as well. So if there's any problems that you have with the startup, or if you're just interested in exactly what's going on. And so one of the tools that we have is called the Windows Performance Recorder. And so some of you have that installed on the machine, so you just go and launch that. Okay, so this is basically a tool that uses a mechanism called event tracing for Windows. So really what we're doing is, when we're turning this on, we're turning on a boot logger. And so what happens is, when the system starts up, it captures all this data to disk into a file called an ETL file, or an event trace file. And so what we can do is we can capture this information, and we can take this off the system, and we can analyze that in a tool called Windows Performance Analyzer. So in this case here, we have several options. And so we have different performance scenarios that we can use. And so two of these scenarios here are related to boot. We have a boot option. We also have a fast startup option. So if we were to go and select boot, what that actually does is it ignores the Hyper file. So this is actually starting from cold start. So you can actually go and you can measure both, so you can actually find out what the performance increase is. And so Sami, if you can kick that off.
Kick it off. Just give it a description.
So this information as well also gets written into the trace file as well, so we can go back and we can analyze that. So if you're capturing, if certain points happen during the process, you can actually add information. So once that happens, you now get the option to go ahead and to restart the machine. And Sami, if you go ahead and just click OK, what we should see now is a prompt that the system's going to shut down, and then it goes ahead and automatically goes and reboots. So when the system starts up, it's going to start tracing. So it's going to capture all of that boot activity. And so we'll have that in a trace file. So we'll have about 7.5 seconds worth of data. And it actually continues tracing. It'll continue tracing for another 2 minutes. So it captures all the post-boot activity as well, because that's the phase when a lot of third-party applications, for example, launch. So applications that have been installed in the start group, or applications that have been put into run or run once keys. So here we can see it's actually still going ahead and it's trying to capture that data. Now, we've actually taken a trace off a machine, so we had that taken much earlier. And so what I'm going to do is just switch back to my machine here. And so I have a copy of the tool I mentioned, the Windows Performance Analyzer. So these two tools actually ship as part of a kit called the Windows Performance Toolkit. So if you went to msdn.microsoft.com and you looked for /performance, you could get access to these toolkits. So what I've gone and done, I've gone and opened up the trace file. And one of the things the tool actually does is it captures some characteristics about the system. So if I have to go and select trace and say system configuration, I can actually find out exactly what the system was that this trace was captured from. I can find out, for example, how much memory. So in this case here, I can see it was a Surface machine. I can see the speed of the CPU. I can see exactly how much memory this had. So this was a system that had 4 gigabytes of RAM. I can also see here, for example, if there was any hyperthreading enabled. So here, for example, we see a number that says F. So this is just a hexadecimal number. And remember I spoke about bit masks, and I said that each one of those bits would represent a CPU? That's all this value is, it's just a bit mask. So if I was to go and open up a tool like Calculator, and if I go and switch to Programmer View, if I was to go and type in that value, so in hex, if I put in F, and I convert that to binary, you'll see I get 4 ones. So each one of those ones represents a CPU. So in this case, if you went back to the physical machine and you looked, you'd see it's actually a dual-core system that's actually hyper-threaded. So the system sees 4 CPUs. Okay, so we have a look at the analysis then in more detail. What we have is we have this Graph Explorer, and this Graph Explorer actually changes depending on what information has been captured inside of that trace file. So we have information, because we turned on a boot trace, we have information related to the boot. And so we can see, for example, the various boot phases. So what I can do is just select that, right-click, and just say add that to the analysis view. And what I actually have now is a Gantt graph of actually the various phases that Windows has been broken down to, or the boot has been broken down into. So we can see any pre-session initialization. We can see when the session initialization starts. We can also see when logon starts, and also when Explorer starts as well. So Explorer being the desktop that you're used to seeing. So what we can actually do with this is we can add some values to this, so we can actually get some core data to work with. So one of the things you can see here is actually this is down to nanosecond resolution. So this is as these events happen, so we can get very, very granular level what's going on. So the boot time starts at 0. Now if I went back and I looked at the original trace, I could actually find out what time that trace actually started. But here we can see that, for example, if we look at the Explorer view, so if we have a look when the desktop appeared and the user was able to interact with that, we can see in this case that it started at 7.5 seconds after the boot trace and finished just after 8 seconds. So as we can see, there's a fairly quick boot.
It's like basic logon times in your companies. Just small interruption there. Actually, this why I said that is that this is the #1 tool that we use for slow logons. If you are, although after Windows 8 was published, there are no more slow logons probably, but if there would be, then this is #2 just to figure out if it's due to group policy or whatever. So you just take a trace. Just remember to have the user account to do a auto logon, so you don't mess it by yourself, just trying to type in passwords and stuff like that. Just use the register key for auto logon, and you can measure the logon phase and then dig into it.
And Jonas, who I can see standing in the back there, the orange shirt, has also done talks about this as well. So his took 11 minutes. So we did it in 8 seconds.
Yeah.
So.
We tweaked this a little bit.
We, of course, can also drill down with this as well. So if we're only interested in various phases, so let's just say, for example, that we're not interested in the post-boot phase, which was at 2 minutes. So what I could do here, for example, is go and copy the end time, and I could just go and right-click and just say, select a time range. And I could say starting from 0, ending at that range, just go ahead and click OK. And what you'll see now is actually gone ahead and selected that. I can right-click and zoom in. And so now I'm just looking at that information. And where this becomes useful is because I can start to add other things to this graph now. So I could, for example, go back and click on the Graph Explorer. And one of the things it captures is it captures disk activity as well. So we can see every file that was being read from, every file that was being written to as well. So these are stored under storage. So if I go and expand that out, and then we have another option here, disk usage. And then you can see that we have various counters based on the various different criteria or different counters that were collected. So you'll see here as an example, there's one that says utilization by process. So again, I could just right-click on that and say Add to Analysis View. Now, because I did this in the same window, it actually puts it in the same graph. So what that means is if I go ahead and I change the filter, if I was to expand that out and was to bring it closer, these values would actually change depending on that. So here we see a list of just processes. What I can do is I can right-click on the column header, and I can just go ahead and select the other options that I'm interested in viewing. So I could here say, for example, let's have a look at the path name. And so I could select that and just click on Done. And you'll see it has now added the path name. What I can actually do is I can drag these around so I can actually group on the path name. So here, for example, I can, let me just zoom out. So I can turn off the graph and I can say, okay, I'm not interested in looking at this portion. I just want to look at the table. So I can just go ahead and say, display the table only. So this gives me a little bit more screen real estate. And I can see then, for example, the various files. I could also go ahead and I could drag the I/O type, and I could sort by that. So now I can see, for example, all the reads, and I can see, if I was to drag by process, I can see all the processes and then each of the files that they were reading. And of course, because we have these nanosecond timestamps, I can actually find out, for example, how much time was spent doing each of those operations. So I can break down the various phases and actually find out exactly what's going on. Okay, so boot was one of the phases that had a lot of engineering resources put into it. The other one, of course, was power. So as we've moved from getting away from desktop machines and moving to mobile phones and moving to tablets and becoming more mobile with laptop devices, power consumption becomes a lot more important. And so it's no longer reliable having a machine that's standby battery measured in hours or measured in days. Standby for machines should now be measured in weeks. And so this is one of the goals of Windows 8, was to look at expanding the life of the system. So looking at exactly what was going on, where the power consumption was inside the operating system, and seeing that that would be reduced as minimal as possible. So one of the things that Windows uses, and we'll talk about this a little bit later on the next slide, is a technique called connected standby. So what the system actually does is use various power states, and so although you think you're actually putting the system to sleep, it's not 100% sleeping. So there still are certain applications that can sit there and listen for certain events. So applications like messaging applications. So you can have your machine in a connected standby state, but still actually have it connected to your Exchange server and still receiving email. So when you open up the device, you'll see that all those emails are there. You don't need to wait for synchronization to happen. So all this power efficiency, of course, relies on the hardware itself. So you need to have a device that utilizes the battery of the system correctly. Of course, you also need device drivers to support those devices. And also, the application model is important as well. So you can do a whole bunch of work and have a really finely tuned set of device drivers and a system. But if you have an application that just sits there and constantly tries to burn through CPU, that, of course, is going to limit the life of the battery. So one of the things that Microsoft did inside of Windows 8 was specifically looking at Windows Store applications, was to go ahead and to see that if those applications weren't being used, that they weren't consuming resources. So if I was to go and launch a Windows Store application and I was to go ahead and switch away from that Windows Store application, that application actually ends up being suspended. So a thread in a suspended state or an application in a suspended state consumes no resources other than the memory. So there's no scheduling that's going on, so there's no CPU that's actually being used. And the system can actually go as far as, if there's memory pressure, it can actually go ahead and force a reclaim of those objects. So it can actually terminate an application. So the application actually gets a notification from the operating system that is going to go into suspended mode. So the application actually has 5 seconds to go ahead and to save that data to disk. So if the user then goes and switches back, it can then go ahead and read this information back from the system and continue the execution of that. Now, another feature was added to Windows 8 for power management was a feature called the Desktop Activity Moderator, or DAM.
DAM.
So DAM works for native applications. And so DAM is actually a kernel mode driver. And so if you have a device that supports connected standby, it actually goes ahead and when you shut down the system, it goes ahead and suspends all of the threads that are running inside of the applications, apart from those that are part of connected standby. So if you have an application such as I mentioned before, a messaging application, it goes ahead and registers with connected standby. So it sees that DAM doesn't actually put that to sleep. So periodically those threads can be woken up and they can go ahead and perform activity, so they can go ahead and, for example, sync with your Exchange server. The system also goes ahead and monitors startup applications as well. So we spoke about that post-boot phase, and so we saw that capturing for 2 minutes. So there's a lot of applications that run by default. So things you put inside of the startup group, things that you put inside of the run or the run once key, they all have an impact on the system. And so the system looks at those and actually tries to group those into different categories. And so it comes up with 3 different types of categories, high, medium, or low. And so depending on certain criteria, it'll appear in those different lists. And we can actually go and perform different actions on those, and I'll show you that shortly. So we just have a quick demo then. We'll have a look at some of the power improvements then. So the first I want to show you is to look at Windows Store applications. And so I can get to those from my Start menu. So this is the machine I use every day in the office. So I've actually gone ahead and cleaned up those because I don't use a lot of those. So my Start menu is fairly clean. But I, of course, can get access to those by searching on them. I can, of course, go ahead and here and select all apps. So you'll see over here, over on the left-hand side, a lot of my Windows 8 Store applications. So I could here, say, for example, open up News. I could jump back, and I could also go and open up, for example, Maps application. And just for the fun of it, in case we weren't sure how cold it is outside, we could look at the weather. And this is now syncing. Okay, so that's obviously in Fahrenheit, because 27 would be great. But it's not. So now I have 3 Windows Store applications that are all running. And I, of course, I can Alt-Tab, which is going to take me between the applications and back to my desktop. Now, if I switch back to my desktop, and if I go and open up Task Manager, there you can see the Windows Store applications. if I right-click on that and I say go to details, it's going to jump to the details tab. And one thing we'll notice about that is, in this case, this one says that it's in the running state. Now, let me just click on the status, and you'll see that there's actually some here that are now suspended. Now, the reason the other one's in a running state is because I actually did something different to it. So these are actually hosted as well, other applications. If I jump back to the Processes tab, if I was to select, for example, News, and select that, and say go to Details, you'll see that it now goes and highlights, because it's a hosted application, we can see the state of that is now suspended. Now this brings up another problem. How do you try and troubleshoot an application that when you tab away from it, it ends up in a suspended state? So there's actually a tool we can use. It's called PLM Debug. And PLM stands for the Process Lifecycle Manager. And so the Process Lifecycle Manager is actually the utility that's responsible for suspending these applications when we move away from them. And so we can get access to that if we have, for example, the debugging tools installed, which I do in my system. So what we can do is we can run a utility called PLM Debug /query. And so this will actually give me a list of all of the Windows 8 store applications that are installed on the system. So let me just go ahead and let me just refresh that, because I've gone ahead and added some new options to that. So here, for example, we can see there we have Bing Maps. Now, as I said, it's active for a certain reason. Here we can see Bing News. We can see here that it's suspended. We can also see Bing Weather is also suspended. Now, the reason this is active is because I've actually gone ahead and I've turned on debugging for this. So I've actually said for this application, I don't want PLM to turn this off. So in order to do that, I can just use the Enable Debug option. What I need, though, is I need to have the package. So what I'm going to do is I'm going to jump out of this and jump back to my applications. And so, for example, there's the weather application. I'm just going to go ahead and I'm going to terminate that. So it's Alt F4 will shut that down. So back to my desktop, I'm just going to go ahead and I'm then going to copy the name of the package. And what I'm going to do is just take this back and just delete the Bing Maps package I had there and add this again. So there's three things that are going on here. The first one is the Enable Debug option, which is just, again, to tell PLM not to suspend this. The second option is then the package that I want this to occur under. And the last option is actually the path to the debuggers. So what I can actually do is have this application launch inside a debugger when the application actually starts. So if I go ahead and I accept those, and you see it comes back and it says that it was OK. So that's now been turned on for that package. So if I was to zoom out and jump back and then try ahead and launch the weather application, you'll see it looks like it's hung. It doesn't get any further. But if I jump back to my desktop, you'll see it's actually now broken into a debugger. So now I have full control over that application. I can then go ahead and look at the various values that I was interested in. So I can go ahead and dump out, for example, the process environment block. If I want to find out, for example, the modules that were loaded inside of that application, the revision numbers, any of that data. Okay. Sami, registry.
Your registry. It shows some task, it's you.
Okay.
Sorry.
I know.
As much as I would like to do it.
I was just put off by the whole cold thing, the weather. I was dreading. I
You
really
just
thought
froze.
it was 27 Celsius.
Yeah,
I was hoping.
I know.
Some changes were made to the registry. One of the big changes was to do with compaction of the registry. So one of the problems you would face in earlier versions of Windows is if, say, for example, you had an application that would go and create multiple registry keys. So let's just say it would go and create 100,000 registry keys. And then would go and delete those 100,000 registry keys. what the system would do is it actually would retain all the space that was available for those keys. So even though there's nothing there, the registry would still be bloated. So if applications kept doing this and doing this and doing this, you'd actually end up with a registry that just keeps growing and growing and growing. And of course that has an impact on the system because the system needs to allocate resources to deal with the size of the registry. So one of the things the system actually does now is periodically, when it goes and loads hives, it can actually go and reorganize that information. So it can go and compact that. Previously, the only way to do that was to actually take the whole machine offline, load the registry hive into the registry editor, export it into a different hive, which was effectively taking all that data and creating a brand new registry hive and then restarting the machine. So now it actually does it on the fly. Also, one of the changes that impacts the client machine is last known good has been removed. And this ties back to trying to boot much, much quicker. Because one of the phases during boot was, of course, to go ahead and to copy the registry key, or copy that registry hive into an additional hive. And then later on actually go and perform a check and find out, did the system boot successfully? So then it makes a decision about whether or not to keep that hive. So in this case, because it was a very not well-used feature, it was removed. And so, of course, the proper way to get access to that now is to look at using safe mode.
So,
this one's you.
This one is me.
All right.
Okay, cool, thanks. Just one note about the connected standby. If you're looking at system processors, it's mainly so that if you take the devices which use Atom processors or ARM, those are the ones that support connected standby. It's the i5, i7 stuff that usually doesn't. So it's Atom and ARM if you're looking for the long battery life and weeks of standby. Just to make a little bit more out of the battery that you have, there are also new improvements on tasking. There's stuff that needs to be running although the apps themselves are in a suspended state. So if the app needs to perform some kind of background tasks, there's a new model for that one. And there's also a new thing called the maintenance tasks. Maintenance tasks is basically combining lots of processes that do some kind of maintaining, like defracking and stuff like that, and putting them just in groups so that instead of having triggered tasks running every 10 seconds, you would have a group of tasks running at one time and then a longer time interval of not running anything, so you can have you can conserve your battery. There's also trigger start services, which are services that, the background services have had states like disabled, manual, automatic, and now they also, most of those, or a huge amount of those, support a triggered start value. I'm going to show you a small demonstration on how group policy comes into this picture, as it's really cool to hear Daniel talk about debugging and stuff like that, but I really need to get into that admin stuff also. So I'm going to show a small demonstration on group policy, but before that, Daniel can show, if you could just show a small demonstration on how the triggered services themselves work.
Sure. So triggered services or trigger start services were actually a feature that were first introduced in Windows 7. And so there's a lot of services that need to run on the system, but don't necessarily need to run unless a certain condition is met. So one example of that would be LM hosts. So there's actually no point in running the LM host service if you don't have, for example, an IP address. And so that's what trigger start services are all about. So I actually have a virtual machine here. And so what I can do is, from a command prompt, I'm just going to go ahead and zoom in on that. So I mentioned, for example, LM hosts. So there's a utility we can use that's built into the operating system called SC. And so in this case, I can go ahead and say SC, and I can say Q, I can say trigger info, and I can say LM hosts, so the name of the service. And you'll see here that it comes back with some information about why the service would start or why the service would stop. So in this case, it says that it's because of IP address availability. So as I said, it doesn't make sense to launch this service if you don't have an IP address. So what's the status of this service? Well, again, I could look at that by using the SC query tool. So I could just say LM hosts, and you can see at the moment that the state says that it's in the running state. So that must mean that currently at the moment I have an IP address. So the reason I did this in a virtual machine is because I can actually easily go ahead and remove the IP address. And so I can do that quite simply by jumping back to my virtual machine manager. And what I could do here is actually go ahead and to remove the IP address, or rather go ahead and to completely go and disable the network adapter. So in this case, if I go ahead and I select that it's not connected, and I go ahead and I click OK, if I then go and switch back to my virtual machine, and if I rerun that SC query command, you'll see now it's actually in the stop state. So an event was risen, an ETW event tracing for Windows. The system actually detected that. The service control manager saw that there was no need to actually have this service running and put it in the stop state. So if I was to go back and re-enable that adapter, we'd expect to see the opposite. We would expect to see that the system actually goes ahead and puts that back. So let me just go ahead and select the network adapter, jump back to my virtual machine. Again, if I up arrow, and you'll see now that service has now re-entered the running state. Okay.
Me. Yes, thank you. As you might know, there might be some people who try to circumvent group policy, although I would never do it. But I've actually had customers who are running proof of concepts of Windows 8 asking me about why their System Center Operation Manager is giving alerts of people not running their group policy service. As you can see on this machine, which is a normal Windows 8 Enterprise joined to a domain, it has the group policy client service, which in Windows 7 would do everything in its power to start up again if you try to disable it. Even if you disabled it from the registry and booted up your machine, you would get it up. It was running again. So now it's not running. That's the same thing as with all the other power savings. Group policy is working in a different way. In Windows 8, group policy is not running constantly. Whenever it is running and doing something, it then waits for 10 minutes of inactivity, and after that it stops. But you know that you should have a GP update running every 90 to 120 minutes, but the group policy service itself is not running it. Instead, it's using a scheduled task to run the GP update for the computer side and the user side. You can see evidence of this from the event log. Just check out the task scheduler operational log. We can see that there has been a group policy event that was running, group policy background processing, which has been done. You could check the task scheduler itself, but you won't see anything there because it's invisible to admins. So you need to be running with the system account just to see it. If you need the system account to do whatever, debugging or digging into Windows, you use the same stuff that you did with Windows 7. So I have the sysinternals tools here and psexec. So just psexec -sid system interactive don't wait cmd.exe, which is now running as as system, and then just go and start task scheduler and go here, Windows, G group policy. Here we have two hidden tasks. Those are not hidden by choosing show hidden tasks, but they're ACL'd so that admins won't see them. These two actually just run common actions that you know, GP update /target computer and GP update /target user. As these are scheduled tasks, these can easily be remote controlled also. So you even can use that info to, for example, in Windows 8 do a group policy update remotely. You've probably heard about the feature of remote controlling group or remote updating group policy, but how it really works is that it uses these hidden scheduled tasks to shoot up the group policy update itself.
Okay.
Go ahead.
All right, so the final two improvements, we'll look at kernel memory, then we'll finish up, we'll have a look at crash dump. So again, performance improvements that were made inside of the kernel in regards to memory management. So changes were made around page file reservations and also defragmentation. So a lot of customers would go to a lot of effort to try and defragment page files. So the only supported way under previous versions of Windows was actually go ahead and to set the system to have no page file, restart the machine, defrag the volume, then go ahead and recreate a page file. And hopefully if you've gone ahead and you have enough contiguous space, then you'll end up with a page file that's also fairly contiguous. Now, all of that goes out the window if the system was to crash, or the system was to blue screen. Because what actually happens is, by default, that information is written to the paging file. And then what the system goes and does is when it restarts, it renames the page file to memory.dmp. So all that hard work you did to go and defrag the page file just got lost because now you no longer have a page file. So what the system needs to do is go and recreate another page file. Now there's no guarantees that that second page file that's been created is not going to be fragmented. So the system actually has some improvements to deal with that. One of the biggest changes, though, in terms of memory management was a feature that's known as memory combining. So applications under Windows, if you went and looked at every single user mode process, you would see, for example, a DLL called ntdll.dll. Now, one thing the system does to try and cut down on resources is it won't go and load a copy of ntdll.dll inside the process address space of every process. What it goes and does is just goes and loads one instance of the data that it needs and then goes ahead and shares that amongst all the other processes. So physically, if you went and looked at the memory, you looked at the pages in memory, you'll just see one copy of that data. So that happens by default. If you go and load DLLs, if you load executables, those portions of that code actually get shared out. Now that doesn't happen for private data. So if I had two applications, let's say for example, if I opened up two copies of Word, if the system went ahead or the application went ahead and reserved a whole bunch of memory and then committed that memory and wrote to that memory, and the exact same data was in one page of memory, in one process as it was in another process, the system couldn't see that. So physically, it would actually need to have two pages to keep track of that. Now, a page of memory on an x86 and an x64 system is only 4K in size. But if you have many, many, many pages that are all duplicates, it adds up. So one of the features, of course, is memory combining. And so what you can do is, on a Windows client system, this is on by default. So this is actually happening in the background. So the system actually looks for duplicate pages inside of different processes and actually goes ahead and combines that into a single page. If you turn this on a server system, for example, on a client, that can mean tens of megabytes. On a terminal server, that can be tens of gigabytes in savings. And so we have a small demo of actually looking at that, and so we can see exactly how that works. So as I said, it's on by default on the client system. So what I've had to do in this case is I'll need to go and turn it off. And so one of the ways I can do that is by using PowerShell. So by default, we'll actually see that if I go and run this command, get mmagent, it comes back and tells me that page combining is actually turned on. So the command to disable it is just disable mmagent. I just want to say page combining. Okay, so that's now been turned off. There's no messages to say whether it was successful or not. It's just come back and returned to the command prompt. So this is back to how it would be on Server 2012. So what I can do to actually show the effects is I can go and launch applications that actually use memory. And one of the ways I can do that is to use a tool called test limit. And what I can do with the command line here is I can say, for example, the -d means that I want it to go and leak memory, and I can tell it how much memory I want to leak. So in this case, I can say 512 megabytes, and I can say that I want it to go and do that once. So if I go ahead and I launch this application, you'll see now that it jumps up in a console. It's come and said that it's leaked 512 megabytes. If I was to go back and I was to run that exact same command again, so I actually have 2 copies. And you'll see there's now a second instance, and we can see they're different because it has a different process ID. Now, if I jump back and I look inside of Task Manager, you'll see there's actually a field over here. It says memory. If you actually look at this, what you'll see is there's actually the working set, and so, or the private portion of the working set. So this actually means that this is the private data of this application that's actually physically resident in memory at the time. So the system actually tries to balance how much of this is actually used between the operating system itself and other applications that require access to it. So here we can see that in this case, both of those copies of test limit, because this system has enough physical memory, this system has 8 gigabytes of RAM, it can easily accommodate all of those pages in physical memory. Now again, this is with memory combining turned off. So we can see each one of those is using 525, around 525 megabytes. Now we can look at this under the debugger as well. We can actually find out exactly what those memory pages look like. So if I was to go ahead and I was to zoom out, what I can do is go and launch a debugger. And let me just select from the file menu. I can just pick here, attach to a process. Now I can just randomly pick any one of those 2 test limit executables. I just go ahead and click OK. And one of the commands we can use is a command called bang address. And so this actually just goes and walks the address space of that application and goes and dumps that out so we can actually see all of the allocations, all of the regions that are in use. So in this case, it's just really a matter of scrolling through. Here we can see the start address, so where the allocation started, where the allocation ended, and actually how large the allocation was, and then any flags that are associated with that allocation. So because I allocated 512 megabytes in hex, that's that. Is that right?
I think so.
So what I should be able to find, let me just zoom up again, is here's the address where those allocations appear. And so that's the start address. What I can do is I can use a db command, which basically means just go and dump out the bytes. And I said that a page was 4K in size, so in hex that's 1000. And so what I can do is go and dump out that page of memory. And what it looks like is most of this is zeros. And if I scroll up, I can actually get to the top of the page. And when I get to the top, you'll actually see that all the system's actually done, or all test limits gone and done, is every single page that's been allocated has gone and written test limit. And if I went and dumped out other pages, I'd see the exact same pattern. So these are candidates for page combining, because it's the exact same data that's replicated not only in this process, but in the other instance of test limit as well. So what I'm going to do is do the safe thing. I'm going to quit and detach from this, so just QD. And what I can do is switch back to the PowerShell. In this case, I can go ahead and I can turn back on this page combining, and I do that by just using enable. Once that occurs, if I switch back to Task Manager, and if I zoom in, you'll see they actually dropped from the list because they were at the top because they were the highest. If I go and sort by name, so I can actually go and find where they are, you'll see they're actually much, much smaller. Because in each one of those, 512 megabytes was duplicated. So the system's actually gone ahead and worked out that of all those allocations, it was the exact same page. So it's gone and taken those away from that process. So the process still has access to them, but physically it doesn't. It just has one copy of it. And so all those other references now point back to that one page. So here we can see a huge saving in physical memory. So that can now be used by other applications and also the operating system itself.
So as the server guys are talking about the hard disk space, And deduplication. This is like the same thing, but with memory.
The same thing, but with memory.
Yeah.
Okay. So the final thing we want to look at then is crash dump improvements.
We still do have crash dumps?
We still have crash dumps.
Do we still have blue screens?
We kind of have blue screens. That's actually one of the biggest changes. It's actually not the blue screen of death anymore. It's kind of like the soft blue screen of death. Because if you look, it's actually a different color. Has anyone seen the new blue screen? A few people?
So they still exist.
This was a video on YouTube. Smiling.
Smiley. Is it smiling or?
I guess it depends on which way you look at it.
Yeah. I think it's like a downward smile.
Do we still have some of those? We do. Anyone know the easiest way to blue screen a system on Windows?
Install Windows. No.
Turn on the computer. Is that Word? I think that's
Word. Is that all we're going to get?
Are you running Windows 8 at home? Okay. I think that deserves an upgrade.
Yeah, yeah.
If you, or you can choose. Would you like to have Windows 8 or would you like?
Would you like to have Windows 8 license or 20 euros for retkeily, sukellus, kiipeily, metsästys, kalastus? Okay.
All right. That was an easy sale.
Yeah.
Okay. The easiest way actually is just to go ahead and right-click on CSRSS, which is a critical system component. So it's actually marked inside the kernel as critical. And so the system actually looks, if you terminate this, it checks that that bit was enabled, and if it is, actually goes ahead and blue screens the system. So what I could do here is just go ahead, and it's prompting me to say, hey, are you sure you want to do this? Because this thing's marked as critical, and I'm sure I want to do it.
Don't do this at home.
Now, I have a debugger attached, so let me jump back to the debugger. Oops.
You said it was easy.
It was.
It was.
The hard part's finding the window. All right. In this case, I could just say ignore. And that's in fact actually not going to crash because I have the debugger attached.
Mm. That's what I thought.
What I could do is I could break in, if this will allow me. I could say .crash, and I could force this to happen. And if I switch back, you'll see now. So this is actually I've heard this called the sad face of sorrow.
Most of you here probably have even seen that Daniel is kind of famous of making blue screens turn to different colors. So do you think that we could do anything about this one?
We could. Let me talk a little bit about some of the changes, other changes that were made about crash dumps, and we'll come back and we'll look and see if we can actually get this to do something different.
Thanks.
So what I'm going to do in this case, I'm just going to go ahead and restart that system. And we'll get that up and running. Let me just do it actually from here, shut down. So one of the big changes was to do with automatic memory dumps. And so if I go and open up the system panel, so here we have advanced options. And if I select that, you'll see there's also an advanced tab. So that's advanced. And believe it or not, there's actually, there is an advanced tab. And this actually contains the page file settings, and this is what this option actually is related to. So in earlier versions of Windows, you had mini dump, kernel dump, and complete dump. So complete dump would try and dump the full contents of memory of disk. So if you had 64 gigabytes of RAM and you selected a complete dump, it would try and write 64 gigabytes of data to disk. Now that's a lot of data to try and capture because a lot of that you're not interested in because that's going to contain a lot of user data. So you're only interested in stuff that runs inside the kernel. So what the system actually did, or what the system does now is, with this automatic option, is it can actually go and scale back the size of the page file. So by default, in earlier versions of Windows, if you selected System Managed, it would go and set the minimum size of the paging file to be the amount of physical RAM that you had in the system. So if you had 8 gigabytes, you get an 8 gig page file. Now what happens with this automatic dump, and you can see this if you actually back out of the advanced options, and if we go back to startup and recovery, you'll see there's an option here that says automatic memory dump. So the system looks at things, how much physical memory is installed in the box, how much of the paging file you've actually used, and also looks and finds out when was the last time you crashed. So if your system crashed any time within the last 4 weeks, it actually expands that page file for that period. Because if it's crashed, there's a high chance that it could crash again, which means that it wants to capture that data. So in this case, if it does crash, you're not going to lose that information. So that, again, was one of the changes that was made. Okay, so let me see. We spoke about changing that. Let's see if I can get back.
And we've got -4 minutes, so.
But we started 5 minutes late.
I know.
So
let's blame the Dell guy.
all right, so let me just restart my machine. Now, what I'm going to need to do is let that start up, and I'll need to attach a debugger in order to do this. So that just logs in while that's happening. Obviously it says my system ran into problems. This was also one of the changes as well. Actually, if I click on send details, and of course we'll send that off. If I look at the view details option over here, I can actually see a list quite clearly of actually what's being sent to Microsoft. And also there's a privacy statement that actually specifies what information is being sent, who it gets sent to, and what is actually done with that. So let me just go ahead, click on Don't Send, and I'm just going to quickly attach a kernel debugger, and let me just retype the information. And I need to actually launch that elevated, so let me just quickly jump out and get that to happen.
Are you stuck?
I am stuck.
Stuck in Zoom it.
Yeah, it doesn't like that. All right, there we go. I've also lost my mouse, but there we go.
But there's no blue screen, so everything else is working fine.
All right.
Circus music also.
Yeah, included.
Okay. Let me go back. Because I lost my mouse, I need to.
Demo gods, please.
All right. Right click. Run as administrator.
Cool.
I could almost do this blind. In fact, I
Touch
was.
enabled.
Kernel debug. So, oops, local machine, pipe. The name of my pipe is a debugger. All right, now I should be able to break into the system. All right, so let me just maximize that window. So that smiley face is just a resource that's inside the kernel. So all I need to do is go and find the smiley face, or rather the sad face, and I can change it to be whatever I want. So what I can do is I can just go and search and find out exactly where the kernel's loaded, because it actually changes now based on various mechanisms inside the system. So what this means is this is where the kernel was loaded. So that's the start address, and this is actually where the kernel ends. So if I go and search in between that region, I should be able to go and find that sad face. So what I can do here is I can use the S command, and so I can just go ahead and say search for a Unicode string, and I can go and say the address, and then I can specify exactly what it is I'm looking for. So in this case, I'm looking for the sad face. And so it's now come back, and let me just break So it finishes that off. It came back with an address where it found a sad face. Now it said this is a Unicode string, so it's broken up because it uses not 1 byte but 2 bytes to represent each character. So I could, for example, go ahead and I could use a command here, du, and then we can see the sad face. Now because I have the debugger attached, I can of course go and write back to that memory. And I could do that by using the EU command. So edit Unicode, tell it the address where I want it to go and write, and then I can tell it what I want to do. So I can put a wink. Dot crash. And hopefully if I can switch.
Thanks. I was actually looking for the changing of the color, but that's even better. So.
There should be a quick app for that one.
Yeah, we'll do it. It's time to wrap up.
Okay, so that's it.
Please do go to the session evaluations and fill those out. Thank you, guys.
Thank you.